Well, let's look at how to calculate average atomic mass. Well, the average atomic mass is the weighted average mass of all natural isotopes of an element by their abundance. And that abundance is written as a percent. So if you want to think of it in mathematical terms, the average atomic mass is the mass of the first isotope times the percent plus the mass of the second isotope times its percent plus the third isotope, fourth isotope, and so forth. When you're doing these problems, make sure you convert percent to the decimal form. In a shorthand formula, you're really looking at the average atomic mass in AMUs equals mass of 1, percent of 1, plus mass of the second isotope times percent of second isotope, and so forth. So let's take a look at an example here. So let's say we've got copper, atomic number 29, and it's got two isotopes, 163 and then 165. So the first one has a mass of 62.93 atomic mass units and abundance of 69.09%. The second isotope, copper 65, has an AMU mass of 64.9278 and abundance of 30.91%. So let's go ahead and calculate what the average atomic mass of these two isotopes of copper are. Well, again, we can use our formula. So we can say the average atomic mass in AMUs would be mass of the first isotope times the percentage of the first one plus mass of the second, percentage of the second. Well, let's go ahead and plug in the numbers. So as we're doing this, the average atomic mass in AMUs, so it would be 62.93. Now we've got to change 69.09% to a decimal, so 0.6909. Essentially, you're moving the decimal over to the left. Plus, the second isotope has a mass of 64.9278, and we can move this over to 0.3091, 0.3091. And if we go ahead and do our calculations, these two plus these two multiplied together, we're going to come out with an answer of 63.55 AMUs. And again, 4 sig figs, 4 sig figs, 4, and then 6 here, so our answer has to have 4. So that's how you really do those. It's the mass times the abundance, which is going to be in a percentage. Now, every once in a while, you may see a problem where you're going to have to determine the percentages. So let's take a look at one of those problems. Let's use boron for this one. Say we're going to look at the element boron. And boron has an atomic mass of 10.81 AMUs. We want to know what the percent abundance is going to be for two isotopes, boron 10 and boron 11. So we got our two isotopes of boron, and we want to determine, we don't know the percents. Well, so if we look at our formula, AMUs, looking for our average atomic mass in AMUs. So it's going to be M1, percent 1, plus M2% 2. Well, we know what this is, 10.81. Don't know what the mass is. Now we know, or we don't know what percent is, so excuse me. We know the mass is 10, but we don't know the percent. So let's call the percent X. So we have 10 times X. We're calling this 10, that's going to be X, plus mass 2 is 11. And seeing it's percent, it's going to be 1 minus X. Because whatever X is, we can take that value and subtract it from 100 and get our second percentage. So we can go ahead and start multiplying this out. 10 times X is 10X, plus 11 times 1 is 11. 11 times negative X is 11, negative 11X. So we've got that. So let's go ahead and do our rest of our calculation here. Start combining like terms here. So what we end up with, we have 10.81. We have 10 plus a negative 11x is going to give us a negative x. All right, so we want to get x by itself. So let's go ahead and subtract 11 from each side. So if I take 10.81 minus 11, that's going to give us a negative 0.19 equals a negative x. And let's just go ahead and make sure my calculations are right there. Turn that on. Oops, let's clear this. So we have 10.81, 0.81 minus 11. And as we can just see, it's a negative 0.19. Well, we want x to be positive, so we can divide each side by a negative 1. So we get x equals 0.19. Now again, that's abundant, so that's going to be a percent. So we're looking for the percent of B10. That was our x, and that's going to be 19%. Therefore, our second boron, or B11, we said it was 100 minus that percent. So 100 minus 19% should, if my math is correct here, so boron 11 should be 81%. So that's how you would do a problem. Again, if you're given the atomic mass and you got to find the percentages. Typically the first one's going to be x, because that's going to be the one that's going to be in the higher percent, and then it's going to be 1 minus x. So hope this helps, and we'll see you next time.